This is what will happen in the test. You may have noticed that there are several different scan methods here, and these scan methods are provided to allow you to put in the minimum amount of information for the pin definitions. So here we tested 3 pins relative to 1 pin, but there are situations where we want to be able to test banks of pins relative to one another. For example, we may have special components fitted here from this row, pins 150 to 155, to an adjacent row 142 to 147. So if we specify those pins 150 to 155 high and pins 142 to 147 low, we can test them not only in an individual way. Here now we're going to test between every possible combination of these pins. You can see the activity of the tester here walking through all those combinations of the pins. But we can also test them in a synchronous way, which would be useful if there are devices connected between these pins. So here it will just walk along the 2 sets of buses that way. So there's a lot of flexibility in how the pin editing and testing is performed. I'm going to cancel that because we can see an actual demonstration of this in practice if we run the test. So let's go back to the home page and we'll start the test running. The test is now running, and the first of the test steps is executing. So you can see the individual tests being performed. As each test step is executed, the routes are displayed on the device physical representation. It's paused now between the first and second test to enable me to just OK that we want to go ahead. So if we carry on now to the next test, you can see this time that we're testing from one fixed pin to a number of other individual pins. Now the final example is quite an interesting one, because this method uses a full pin-to-pin test. If you work out how long it would take to walk through all 155 pins relative to one another using a linear method, it would be an absolutely prohibitive time. One of the options we have in the system is a binary algorithm pin-to-pin test, and what that does is to ensure that every possible pin of a group that you specify has had the electrical test performed on it in such a way that there's been a complete polarity reversal between it and any of its neighbours. So what that does is to, in the case of this 155 pin test, it makes a complete test in only 7 routes. The pin editor for this is shown here, and you can see that the layout of the sequence has only resulted in some 8 steps, and if we click through these you can see what they will be. and this enables you to verify that in fact the application of the test voltage is as you expect. So by selecting pins 1 through 155 and the scan method pin to pin, we've been able to completely test this 155 pin device. Okay, that completes a look at the Reflex 950 basic test capability.